Trig substitution example number 4, and of the examples that we've done, this is by far the hardest. I'm looking at it and I see this 9. All of my inverse trig functions have a 1, but it's the closest to sine. And this is the derivative of inverse sine. My main issue is there's no way to get around that this has to be a 1. So what can I do to this thing to make that 9 turn into a 1? Well, what if I factor out a 9? 1 minus would be 16/9 x squared. Now, do I have a 1? Well, yeah, but I also have this 9. What the heck do I do with that? Well, hey, look. What's the square root of 9? Well, is this not the same as this? One square root of 9, 1/3. If I multiplied that back, I would get the same thing. So that becomes a constant that now I can take out. So it's just dx over the square root of 1. Now I have my 1. Yay! 16/9. Well, again, I'm trying to make this something that I can square it. Well, what's the square root of 16/9? Well, can I go ahead and rewrite this as 4/3 x squared? Okay. Now it's looking a whole lot more like this, and it probably would have helped if I'd have made that a u. What if I let my u be 4/3 x? My du is going to be 4/3 dx. Get rid of my 4/3. Okay. So I'm going to go ahead and fill it in. I got 1/3 times, go ahead and put my 3/4, the integral of dx, which will be my du, over the square root of 1 minus u squared. I'm going to integrate that now. My 3's cancel, so it's 1/4. The integral of this is inverse sine of u plus c. My last step is to fill my u back in, so this yields 1/4 inverse sine of 4/3 x plus c. It's a little complicated. The good news is usually they don't put anything that complicated on the AP test.